Well, hi, good morning. Thanks so much for joining me here in my shop for another round with this radio. I think what I want to try today is to do a preliminary alignment. It's been my experience in doing this kind of work that the first time you try to line a radio is you more or less have to write it off to education. As you learn the procedure exactly, even though they're all very similar, there's often little details that are slightly different. And that's what I found. Now, is this radio really ready to be aligned? Is everything repaired in it? We don't really know for sure. I still had difficulty with this IF can. I still cannot put a tool down through the top, and I have not explored from underneath. So this is the second IF. This is the first thing we have to tune in this radio if I'm going to align it. So we'll end up facing this problem head on, so to speak. And also I've discovered page 2 of the schematic. So we're going to start out and go over page 2, which has all the alignment instructions and some other very valuable information. I should have looked at page 2 a little earlier, but you know, it's never too late. Here we go. So this is page 2. Let me shrink it down a bit. And again, this is somebody has put together pages from a longer document and kind of shrunk them onto one piece of paper here. Once in a while there are copy mistakes made in doing that. This one looks pretty good. Okay, well, let's just start. We're just going to run through everything that's on here and make sure I've taken advantage of all the information that's available, because I haven't done that to this point. So here we see a C600 walnut plastic, ivory plastic. Plastic is the word, and that's what I've got. Anything here that might be surprising? So there's the intermediate frequency. It's designed for a intermediate frequency of 460. I think some people would argue having this as a 0 is actually a little bit problematic, and it's better if the last number is a 5. So that's why 455 is really quite common. The exact reason for that I'm not going to explain, but it does have to do with images and other things like that. Undistorted output. Nickel permanent magnet. Voice coil impedance 3 ohms. That's at 400 cycles. Cone diameter. Different sizes for, I guess, different radio cases. We got the small guy, 5 1/4. Tubes, yes, except in this radio the RF amplifier is an SJ7. 35L6, no surprise there. In this radio there's a 50L6 sitting in that position, which we really haven't dealt strongly with yet. Okay, we'll get to the alignment chart itself next. Let's look at these diagrams. So this is a helpful diagram. There's the 460 kilocycles again. Second, looks like LF. That should be IF. That's a typo. This one looks funny too. Just top and bottom. Look what they've shown. They've shown a screw. But what I've got are hollow slugs. This one, I can push my tool right through the top slug into the bottom slug. This one, the hole seems to be occluded by something. These two cans, when I look at them, are a little bit different. They're not identical. Slightly different design. So maybe this one is a core, maybe this one is a screw, maybe this one's been replaced. That's quite the maybe. I really, you know, I would give that 0.1% possibility, judging from the wiring underneath. And so here's 3 other adjustments here: antenna, RF tuning, and the oscillator. And previously, when I was testing the radio, I had flipped it over, and then accidentally or in error thought this was the antenna terminal. I did some testing with the antenna connected here when I really should have been hooking it up over here. No problem at all now. Tube and trimmer locations. So this is a chart. Let's take a look at this. This has voltages on it. Let's go to the output tube and look at the plate voltage, 132. I think this is the screen voltage. 70, 85. So I'm not sure what's going on here, but I think we might want to run through all those voltages again and double check. Let's see, the plate voltage out here is all of 45 volts. it's quite common to be very, very low plate voltage on these tubes. I don't exactly know why. I don't exactly know why, but they commonly are very low voltage. Now these are the ones I was testing. What was it? It was something I thought was just too low to even operate the tube. But look at how low these are. 70, 70, 70. Look at this. 47. 47 volts on the plate. I've never seen anything that low before. I don't remember measuring 47 here either. 24. It's got is this an asterisk? Okay, so what's the asterisk all about? All voltages measured at 115 volts, cycle volume control at minimum, no signal input, phono radio switch, and radio position. Here's the asterisk. Indicates AC voltage measured with a 1000 ohm per volt meter. AC voltage. 24 volts AC. 24. So I'm going to guess what you're measuring here. I'm not going to guess. I'm very certain. You're measuring the voltage of the heaters. As you work your way through the string, the voltage is going to start close to the supply voltage and just go down, down, down. So that's where you're getting 150. I'll take that back. This is the rectifier tube. I'll take that back. This is probably I'm going to say too much. I don't know which pin is which here for heater and plate and all that. That's why you're seeing these AC voltages, these weird AC voltages, just part way through the heater string. So no doubt. This is connected to this. This is connected to this. This. This is connected to this one. So, we could do this too. We could run through the string. And that's actually a good idea, Jim, because this first one is a 50. And so who's first in line? Maybe look at the schematic. We might be able to figure that out a little bit better. But anyway, you have this voltage chart. Yeah, I'm going to repeat these voltage tests before we do the alignment. It won't take long. All voltage measured with respect to B minus, not the chassis, unless otherwise specified voltages are DC measured with a 20,000 ohm per volt. So this is a pretty good meter, 20,000 ohm per volt. So we should get the same kind of readings using my very good high impedance VTVM meter. And now we'll just take a look through the alignment chart, just in case there's anything. Caution, use an isolating transformer between line and receiver to prevent damage to test equipment. So what they're saying here is, watch out, this is a hot chassis receiver. You plug it in the wrong way, and there's a chance you're going to blow a fault current right through your test equipment. And under the wrong circumstances, something's going to catch fire. Something's going to pop and burn up, something like that. Connect low side signal generator B minus. In steps 4, 5, and 6, use method B. So method B is using a loop and impressing an antenna signal. You'll see that because I already shot through these this morning. If several peaks are obtained, use method A. That's interesting because method B, I would think, would be the one that puts less on the radio. If several peaks are obtained in steps 4, 5, and 6, and they're done at frequency, tune-in signal. Very interesting. Okay, so are we ready to read through these? Anyway, I think we are. I don't think there's any other notes here. I do have an isolation transformer incidentally operating. I also, if I'm really concerned, I whip out my voltmeter and look for dangerous voltages before making connections. Okay, because the worst way to make a mistake is to think you're not going to make it when you're about to make it. That's really the worst way. Connect oscillator 2, test oscillator setting, dial setting, adjust for maximum output. So this is just the IF. Will at least get through this today. 460, 12 SK IF amp, grid in series with a 0.05, same thing here, 0.05. No, this isn't the same thing. RF section of gain. So you move it back so the signal input is not going to throw off the very circuits that you're tuning. Repeat steps 2 and 1. Ad infinitum. So let's just concentrate on this. I mean, if this goes well, maybe I'll move on further, but I don't think so. Voltage is first. So I'm going to stop and rearrange the screen here that we're looking at. So this is on the screen the whole time while I'm doing the testing. Well, we're ready to start here and take a few tests on these tubes according to that chart. Let's just check a couple things. I've got the B- connection made there. My meter set to 150 volts. And we'll start with the 12 SK7, which in my case is a 12 SJ7. I'm going to guess those tubes on the diagram are shown in their proper pin relationships. They've been careful to do that. They've shown the key, and on the 12BE6 they've shown the gap. So I think they're really trying to say this is the way the tubes are turned on the chassis. So let's just double check. If I look at the 12 SK7, the key is kind of pointing at the 12BE6. So we take the 12 SK7, the key is right there, it's pointing right at the 12BE6. So we can be pretty sure these are the same way around. That's helpful. We're going to start with, I'm going to avoid the AC voltages right now and just check the DC voltages. So we would want to start with pin number 8. That would be the easiest one. Pin number 8. It's going to be 47 volts, supposedly. Not going to be anything until I turn the radio on. We're going to get a big 0 until I do that. Okay, power's on. Set's on. Now I've been leaving the dim lights in the circuit while I work on this radio because I've noticed that the operating voltage, which is shown on here, is always within the normal range. Look, it's 116 right now. It's going to run around 117 with the lights. If I supply the full output from my isolation transformer, it's going to be more like 125 volts. So I'm lucky in a way. I can keep the dim bulb in the circuit for protection, but yet the radio is operating at its normal voltage. Normal voltage, normal current, normal everything. And that's good if we're going to be doing voltage tests. Okay, by now it should be warmed up. Once again, 150 volts positive upscale. Starting with pin number 8. Expecting 47 volts. So on the 150 volt scale, that comes out to 65 volts. That's quite a bit more than 47. I should be able to go 2 pins over and get the same voltage. 47 here. 2 pins over. That wasn't 47. It's more like, yeah, same thing, 65. My meter might be a little out, but it won't be that much out. So interestingly enough, while I was worried about these voltages not being high enough because 65 sounds low, in fact 47, I am really quite surprised. 47 volts. Just didn't think you could really operate these tubes at such a low potential. It's 47 back to B-. What happens if you read that back to the chassis? So I have only one ground on. I can do this. Pull it right off. Stick it on the chassis. What do you get then? I don't think it should be any different, but let's find out. It's actually a touch lower. 60. Okay, I'm going to shut the radio off while I make the B- connection. Again, in case I get it wrong while I'm doing it. In case I short something out while I'm doing it. A bit of a mistake here. I'm holding onto the probe of my voltmeter with one hand while I'm bare-handing connections into the radio here. Probably not a good idea to be holding on to this. Okay. There we go. Back in business. So, okay, so is 65 a problem? I mean, should I knock it down to 47 somehow? Let's try the 12BE6 next. So, I'm going to look on here. The gap is very obvious. pin 6 should have 70 volts. So 70 volts is here on my meter. I know you can't read the numbers on it right now, but it's a 150 volt scale, so you can get a feel for it for sure. And we're going on pin, look again, pin number 6 to find 70 volts on 6 and 5 in fact. There's 6. 70 volts and 5. 70 volts. That's so we get the right voltage on this tube, but the wrong voltage on the other tube. And a higher voltage too. Usually resistors drift high and voltages come low over time. Okay, let's go on to the next tube. 12SK7 tube. This is the IF amplifier, and we should find 70 and 70 again. Pins 8 and 6. Yeah, same as the other 12SK7. 8 and 6. So I see where they say the key is. And the key is pointing this way, pointing at the output tube, or the 12SK. 12SQ, yeah, that's it. Everything's checking out. Pin 8 is right here. 70 volts. Also, along with pin 8, we should get it on pin 6. Just 2 back from 8. 8, 6. Okay, everything's fine there. 12SQ7 now. We should find 45 on pin 6. 45 volts. And notice the 0 on pin 7, that's the start or end. That's the start. I would look at it as the start of the heater string. Just noticing that. Okay, get the right number in your head. Pin 6 on the 12SQ7. Pin 6. Okay, so it's pointing this way. That's the same as the diagram. Pin 6. Pin 6 got this long wire on it. Pin 6. And a bit of a dark here. Oh, too much chance of a short circuit. Other end of the same wire. Well, we're going to get the same. Hey, nothing there. Oh. And this wire's not going where I think it's going. Eight, 7, 6. Way out. 6. Rating 45 volts on 6. And it's supposed to be 45 volts. Good. Now we're into the output tube. Looking at 70, 132, 81, 3. Find all those voltages. Okay, so it's pin number 3, the plate. And so the output tube is a little hard to access. So you want to start with pin 8. Is that right? Pin 8, 3.8 volts on pin 8. Done with the, was it a 20,000 ohm per volt meter? So pin 8. This pin right here. Tiny voltage. We're on the 5 volt scale now. And it's 4 1/4. I think that's fine. Okay, next one coming around. We can pick pin 7, 81 volts on pin 7, 81 volts. I'm not doing something right, I think. Pin 7 says 0. Whoa, 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 getting confused on which tube I'm looking at. Pin 7, 8.5 volts, no asterisk. 6, so we got, wait a minute. I'm reading the number wrong. So the 3.8 is on pin 8. Oh my gosh, I got this totally wrong. Totally wrong. Start again. Start again with the right tube. That's my problem here. Making multiple boob-ups. Part of the problem is that I can't see the diagram from here. It's on my big screen in the shop here, but I can't see the part I need to see. So I keep standing up and looking over and then forgetting what the heck I'm doing. So pin 8 should have 3.8 volts. 8, yeah, I did that. I did that okay. Did that okay. That's okay. It's a little more than 3.8. Next one should be 81. Next pin down from there. Next pin down from there is this one. It's definitely this one. We're getting nothing there. Something's definitely not right. So the meter, every time I tap it, the meter does little jumps like this. Sometimes that says to me that's AC. That would be AC. Oh, for sure. Okay, so I'm just looking at the wrong parts of the diagram here. I'm totally making this a mess. Pin 7 should be 81.5 and it's not. Let's try pin 4. Pin 4. Pin 4. So 8, 7, 6, 5, 4. Way up in the top there. Down on my hands and knees to do this. Pin 4. Okay, I'm definitely getting a voltage 70 volts. Pin 4. Now we gotta get up and read the diagram. Pin 4. 70 volts. There we are. Pin 3, 132. So just about to the top of the scale here. Pin 3 would be here. Well, that's a 120. Okay, and up there it says. Oh my gosh. 132. A little low. And that's it. So what happened to pin 7? Let's go back to pin 7. Something up with pin 7. Pin 7. You know, 2 and 7, that's got to be the heater. Maybe they dropped the asterisk by accident. That would make some sense, you know. Pin 7 on a 35L6. I have the feeling they made a mistake there. Pin 7, 35L6. 35L6. It's certain to be the heater, I think. 35L6. Even though there's a 50 in there, they're the same inside. They better be. So the pin we're interested in is pin number 7. Pin number 7 is a heater. So I really think that's an error, and it should be an asterisk beside it. Would that make sense? So you see the asterisk on pin 2. 2 and 7 are the heaters. So on one side you got 85 pushing, and then you're left with 46 on the other side. That's about a 40 volt drop on a 35L6. Makes sense? This will be interesting. We will go through the voltages of the heater strings and compare them, because this has the wrong tube in it. It might be interesting to see what's really going on in this radio. So we'll look again. No, we won't. We will switch to AC. We're ready to do that. We'll switch to AC. We're ready to do the heater string. Okay, we'll start with the 150 volt scale. And I figured which one that I think was the starter, the 12SQ7. So we would get 12 volts AC on pin number 8. Yeah, okay. Now, 12SQ7. So that guy, pin number 8, 12 volts AC. I'm going to change my meter here to 50 volt scale. Oh, I almost forgot. Change my probe. This takes a resistor out of the circuit and recalibrates the machine. Or let me put it this way, I calibrated this operating this switch for DC and AC. So I better operate it or it won't be calibrated. It'll be way off, in fact. Good show. Concentrate. Pin 7, 0, pin 8, 12. The risk of interference. I got too many reflections in here to set the lighting up conveniently for everyone. Every time I distract myself, I think I better check again. 8 is 12, 7 is 0. 7 first. Is there a 0 over there? 0. And then here we should get, oh my gosh. Oh, so, okay, something not quite right with that. I touch a heater and get that kind of response? Yeah, that's right. Yeah. Totally wrong. What I'm doing. Am I? Pin 8. Pin 8 should show us 12 volts. Sorry about this, but it's just the way it goes. Pin 8. Think, man. Do an 8. 8 is this wire here. The one that comes down to here. There we are. Now we got ourselves a reading. 50 volt scale. We're reading about 10 volts. Okay, what's it supposed to be? 12 volts. That's okay. Let's keep going. Because that tells you what's really on that tube is 10 volts. Let's do that again. Between 7 and 6. You know what? I'm going to do this a different way. I'm going to do this just a wee bit different. Why don't we just straightforward look at the voltages right across instead of measuring them as they drop along the string and comparing them to the chart? Why don't I just measure them? I have an isolated meter here I can use safely. Measure them right on the tube heater. Let's see what we see. Yes, can we see? AC 20 volts. Because the meter is not grounded anyway, I can just go anywhere in here. Anywhere I like. I have to touch two things at once. Ooh, that's a tough challenge for Jim. Two things at once. So we'll start right with the same tube. 12 SQ7, 7 and 8. What is the voltage across pins 7 and 8? I'm going to have to, I can forsake the other meter now. Blast some light into this baby so I can see. So this won't look very good for you, but for me, this is what I need. As long as you can read. This is what the excitement is all about anyway. Ooh, that's a lot better. 7 and 8. Okay, so 7 is right to B minus, and 8 is the same as this. .7. I'm going to write these down. Again, our supply voltage is 114. That's certainly 115. I think is the stated voltage to do these tests at. I'm looking. Yeah, it says right there 115. So I'm right there. I'm right there at the right supply voltage. So I'm going to write these down because I have a feeling at the end of the day we're going to need this to make a judgment about that 50L6. Decide if that's really a bad actor in there or not. So this first tube was the 12 SQ7 and I measured so 10.7 volts. Actually I just measure it. Careful, man. Right here. 9. I thought it was. What happened there? Did anybody see that? I must have a bad connection. Ooh, don't push the radio over. Yeah, there we are, 10.5. Come on, meter, what's going on? I have to have my eyes in two places at once. That's bad news. Saw it again, 10.6. You saw it. It's 10.6. 10.6. 10.6 volts. So they're probably all going to be a little low, and then we'll find the output tube to be a little above 35. That's my guess. That's my guess. Next tube. Don't put these down. Let's keep going. Next tube. 12 BE6 heaters on 4 and 3. 3 and 4. It's typical for these tubes. 8, 7, 6, 5, 4, and 3. That's 3 and... Oh, come on. 3 and 4. Jeepers creepers. Zero. What the heck did I do there? This radio is working, isn't it? It's making some sound. It's making some funny sounds. Crazy I didn't check that right away. 1, 2, 3, and 4. I think I had the wrong 3 and 4. Now I got the right 3 and 4 this time. 3. Don't short anything now. Shorting this is not a good idea. It's plugged right in the wall, kind of. Oh my God, is that really what's there? 3.6. Really? I can't. Oh! What? I think I saw 18 there for a moment. Oh. Wham, did I switch? 1, 2, 3, and 4. 3 and 4. 3, watch your hand on the chassis, Jim. Don't touch it. 3 and 4. Looks like it's over 15 volts. Over 20 volts. Yikes. Come on, really? So I seldom do these tests, testing the, in most radios, well, I shouldn't say that. In many radios, the tubes are in parallel. Oh my God, 22 volts on the heater of a 12 volt tube. Come on, really? Holy smokes, I'm surprised. That should be glowing like a light bulb. Oh, it's got a metal cover on it. Yeah. Let's investigate how much glow is in that tube. The way I'll do that is turn the lights off in the shop and see if it gets dark. It may not get dark. 22 volts. Well, that's the wrong way. Right now, I don't know how this is going to work on a camera, but I'll be able to judge. Here we go. She's in the dark. I'm looking down at that tube. See nothing unusual going on at all. And where's my mirror? Now, you might be able to see in the mirror. So we're looking. Yeah, nothing unusual going on. There's no light bulbs in this radio. Yeah, I cannot see the heater at all in that tube. Cannot. So those two things you're seeing are the output tube and the rectifier tube, and the other tube is I'm not showing up at all. So 22 volts, and it doesn't look like a light bulb. Okay, do I believe this? How can it be wrong? We're on the 200 volt scale, 22. Oh my gosh, 12 BE6. It's a 22 BE6. 22. What's left for the rest of the tubes? Wow, this is a totally unexpected result. Next guy we'll do the 12SJ7 down in the corner here. And we should find it on 2 and 7. Typical. You can bet the engineers spend a long time discussing which pins should carry the heaters, and should you put the plate pin on this side and put the grid pin on the other side to space them out. And there's probably a lot of discussions on these tubes around that idea. Okay, concentrate, man. You're going to make another mistake. 7 and 2. 7 and 2. 7 and 2. 7. And 2. 2 I can get on pretty good here. 7 is a little tricky. Not from this angle, I can't do it. Okay, for some reason I'm switching hands. I'm just dangling myself up here. Something terrible. Two. Two and 7. $31. What is wrong? How can I get 31 there? You know what? I think my meter might be acting up here. Let's just give that another try. I'll plug it right in the wall and see if it gives the right number. 200 volt scale. This thing has done funny things here and there in the last little while. Like dirt on the... Okay, get the easy one first. And then go after the other one. That's more like it. Now I gotta wonder what happened to the last test. Okay, the last test was 10.6, so I'm gonna trust it. 9.2, but it should be 12. 9.2. Oh, wow. They're all over the map. 9.2. It's going to lead into another whole area of investigation. So I have three good tube testers. 2 of them don't do anything with current flow through the heater. They don't measure it or anything. They just supply a voltage, and whatever the tube takes, it takes. But I have one tube tester that actually will tell you the true tube current, the heater current. I may end up having to put these tubes through that thing. So that was the 12SJ7. This is just bizarre. Okay, now we'll do the IF one, the 12SK7 in the middle of the radio. It's pins 2 and 7 again. 2 and 7. 2 and 7. So I'm looking to make positive identification of the key. It's really hidden from view. There it is. So looking for the key slot. There it is. 8, 7, and 2. 7. Hold it still, man. And 2. I can't see the bloody meter from here. 10.5. Is that what that said? 10.5. 10.5 on it. 10.5. 12SK7. 10.5. What do we got so far? We got so the 12BE6 with 22. I'm going back to that because for sure that was bogus because of my meter acting up. There's no way there's 22 volts on that tube. Let's go back and prove that by going. It's 3 and 4. $11.2. Okay, you know what? Isn't that interesting? That's about half what I got before. 11.2. That's more realistic. Explains why the tube wasn't glowing like a light bulb. In the early tubes, the filament temperature had to be raised to a very high temperature, almost white hot like a light bulb. Later, they discovered by doping the cathode with various other materials, including some radioactive materials and eventually coatings over the surface of the cathode metal, would lead to a good emission at lower and lower temperatures until finally they got down to red. So in a red and orange. So in a radio like this, when you look at the heaters, they're all red and orange. That's because they're doped, fixed, they're advanced, they're engineered far more than the very original one. So if you have a very, very old radio from like 1926 or 27 or even older, and you turn it on and the filaments appear to be more like light bulbs and you're panicking, and there's no need to panic. Well, maybe a little panic's always helpful. If you're not sure what's going on, a little panic is good at times. So now we're left with 2 more tubes to do. One is the rectifier tube. I'm not going to bother with that. The other one is the output tube. Now, this is the one. This is the 50 L6. We should be finding 50 volts. Not with that. Not with that I won't. So same thing again. Heater almost certainly is 2 and 7. Yep, 2 and 7. Missing asterisk. 2 and 7. They're fairly easy to get at. 2. Oh boy, hold still. And 7. Oh! Anybody else see that? Let me try that again. 2. Hold still, radio. Don't be moving around when I do this. Don't move. It doesn't hurt that much. Well, that's a little more like it. How did I get that other reading? 45. I saw 45 on there. I'm not pushing very hard with these test leads. It's an AC voltage plugged in the, wow, it's not really plugged in the wall, plugged into my, let's just say I'm scared. I'm suitably scared while I'm doing these. Scared of short circuits. Now everyone's scared. What do you get there? Oh, for crying out loud. I tell you, man, what kind of a meter is it that when you're in the middle of using it, it decides to go to sleep? Jeepers creepers. Careful now. We saw it before. I'm just having trouble making firm contact here. Let's see, one of these has the hole in it. This one here I can hardly see. That gives me a good place to push the meter lead. Supposedly. Oh, was it there? Oh, I know, I can look up at my big screen TV and see the meter. 5 volts. Come on, what am I doing? Ooh! Now, don't get too excited. There, you're going to knock the radio right over. My hands are just, look at, my hands are glistening with sweat. Oh, I did it. That was a short right from the heater right to something else. I saw a spark too. The radio's still working. Am I going to ruin it doing this test? Okay, there. No. Oh, for crying out loud. Okay, we're going to try something different here. This is stupid. What's going on? Power off. Flip leads. This is the most important reading. This is the one that is probably upsetting everything, if everything is upset. Or it alone is all upset on its own. In other words, there isn't 50 volts here to run this tube. I think I saw 45. Okay, we're going there, and then we're going here with my sweaty hands. Give me a different clip lead. My special one. Okay.
Okay, there we are. We are on the correct two terminals. Clip on the meter. Get a reliable reading. A little interesting in itself, watching the voltage vary. Now it should be 50 for the sake of this tube. .44 is not bad. 50 would be better. 44. I wonder what these numbers add up to. So the one I haven't measured is the voltage drop on the rectifier tube. I'm going to have to measure that too. So here we're getting 45 volts. Okay, and I was just thinking hard there for a minute. That's why I went quiet. 35Z5. I don't want to make any mistakes on this. So we see, what do we see? We see 81.5. You see there's no, and the asterisk is there. And on pin 2 and pin 7, 115. That 115 is probably the, it's got to be the heater one. But I'm going to make sure. 35Z5, I don't want to make a mistake here. I don't think it's any different than the other tubes in terms of which pins are the heater. 35Z5. When I was a kid in public school, I made a time machine in my shop. I had a shop. I made a time machine in my shop. I took an old radio, got some tubes, kind of jammed them somehow in the radio, and I actually soldered wires to the heater pins and hooked up a battery. Got the two or three tubes to light up. Called my folks in. Look at my time machine. I had a bunch of other parts in there. They were never impressed. Yeah, I could not impress my folks no matter what I did. 35Z5, 2 and 7 are the heaters, with 3 being the tap off, but we're not using the tap off in this radio. So if I look, I should see pin 3 is wide open. Nobody touching it, and it is wide open. Good, all checks out. So 2 and 7, what is the voltage between 2 and 7? Oh, I've got this in there still. Okay, so I think I can leave these safely laying on my bench for this test, and then I'll take them off next time around. In fact, one of these is the lead to the, no, let's just do the same thing. Let's just carry on. Yeah, don't even finish the thought. Here we go. Rectifier tube here, pins 2 and 7. 2 and 7. 2. Okay, it may not look like I'm touching 7. It's the same as 7. And how's that meter? 16 volts already. Pin 2 is, okay, hold still radio, don't go anywhere. .28. Oh, once again, the meter is bonkers. You can see the decimal point kind of comes and goes here. Yeah. Dirt in my meter. I'm wearing the meter. I'm wearing out my meter. Now I gotta make, this is where the mistake gets made. 2. Yeah, wrong tube, first of all. That's a good mistake. 2 and 7. Give me a decent reading now. I saw 11. Hold still. What? I got 28 now. So what do I got? I'll put this on the 20 scale. Oh, it's supposed to be 35. I'll put it on the 20 scale. Let's go back to the wonky 200. Expecting 35. Right, get your head right. Get the right tube. 35 on the right tube. There we go. Don't knock it over. 28. Okay, that's probably the truth. 28 volts is probably the truth. 28. So that's the guy who's getting ripped off for voltage. 28. Write it down. Write it down. 28. 28. Now, add these guys up. Oh, I'll do it in my head here. 21.8. 21, 22, 31, 41, 41.5, 41.5, 45, 5, 6, 86, 28, 5, 6 and 8 is 4, 1. Okay, so we got right back to 114.5, so that's correct. That's what we're supplying in here today is 114. Oh, you can't see that. Up here now. 114. So what that means is all these voltages add up to the supply. That means the readings were correct or valid, or could be considered valid. Without embarrassing yourself. So what do we really get? So we get, instead of 12 we get 11, instead of 12 we get 11, instead of 12 we get 9, instead of 12 we get 10, instead of 50 we get 45, and instead of and this is the rectifier, instead of 35 we get 28. So well, kind of basically what's happened here is every tube is running low because of this 50. So if we were to put a 35L6 in here and it did in fact drop 35 at that time, that would leave 10 more volts to be spread out. So this guy needs 7 of them. That would leave 3. 1 for everybody. So he's pretty good. 1 for him and 1 for him. They're pretty good then. One, it's not quite adding up, is it? So how bad is it to run a 12SJ7 on 9 volts instead of 12? 9 volts is a bit off. Is this worth worrying about? Can it be that the radio doesn't operate right because of this? Because of incorrect heater voltages? That's hard to believe. That's very hard to believe. So what happens if you don't have the cathode hot enough? Like this cathode would be a little cooler than it's really intended. Well, its emission will be low. And I'm going to guess the plate resistance will be higher. I'm just guessing though. Generally, I think, sort of a high level, if you don't have the tube operating within the range it's designed for, then it's not going to do what the engineers intended it to do. And it's not going to do better. It's only going to do worse in some respect. So worse for this guy, this is the RF tube at the front of the radio, worse would be not as much amplification out of this tube. Worse yet, if the heater is really low enough in temperature, the heater can operate in a temperature range that is dangerous for the heater. You might think it's, turn it on, it's safe when it's cold, and all the way up it's just getting more and more operational until you get to the top temperature, and then it's fully operational. But in fact, there are metallurgic effects going on in the cathode on the way up, and if you stop at the wrong point, you can stop at a temperature that is basically unstable for the metal of the cathode, as I understand it. Now, I just think the tube's going to blow up in 2 seconds. No, I think what happened is it's going to degrade slowly over time, but much faster than it was intended to. And it could well be when we find bad tubes in a radio that something like that has happened to that tube. That the tube, if it's the output tube or the rectifier tube, it's probably just worn out from heavy use. But the rest of them, they should all kind of, assuming they're all engineered in the same kind of work ethic, if you like, they're all working at a similar strength, then they should all wear out in the same way, at the same rate, at the same time. So maybe if you find one of these guys, one of these front end tubes, is sick, the radio has made it sick in some way. And I've seldom done this in these radios with the series heaters. Of course, the reason I would seldom do it, like if this radio had a 35L6 in there, I probably wouldn't have done this. It wouldn't be prompted. It's because I'm curious about the effect of the 50. So you could argue the most important tube in the radio is the output tube. It's the one that's pushing on the speaker. It needs all the help it can get. Often it has an elevated voltage on the heater because it's actually developing a lot more power and a lot more heat in this tube than these other ones. It's the same current going through, but with a higher voltage. There's more heat and a higher temperature happening here. What am I going to do? Well, okay, I think I know the situation now. It's all exposed. I'll just carry on, and if somewhere down the road, and it's not a long road now, the radio shows some kind of misbehavior, maybe I can link it back to this kind of stuff. I doubt it, frankly. Doubt it very much. So that's an interesting thing to look at. I have to do a lot more reading to find out exactly where the danger zone is. If you run a 12-volt tube at 9 volts, are you in effect killing it? You wouldn't think so, right? You think, oh, the lower you run them, the longer they're going to last, the less work they do. But no, there's other factors too. Not so much in the heater current, but in the plate voltage, screen voltage. These things are out of balance. Some behaviors in the tube occur that you don't want, that you're probably not aware of. And me too. I'm not aware of it either. So I've got a little more serious in my later days here at making sure the correct voltages are on these tubes. But I'm not going to do that here. Let's carry on. The next issue really is the problem with aligning the IF and the one coil that appears to be blocked. So I'm going to turn the radio off now because I don't want it on while I'm doing this. So get rid of these clip leads before something bad happens. And we'll try to figure out what's going on with this IF can. It's this one here, which for some reason is blocked. And when I tried poking it, remember the radio went crazy? All that's still there. But the radio's not on right now, so I'm going to try to feel up for the slug. I get the impression there's a screw in here. Like it showed. Let's see if we can get a grip on the screw. Sure enough, there's a screw in here. No doubt about it. So that means there's a screw down here, there's a screw up above. We got to get to it. Unless by some wild chance this thing is properly aligned. This gets all the way back to pulling the can off this thing and everything. So what has happened at the top that it's occluded from vision? It could just be an enormous amount of dirt on top. If I just scraped away at it, all would be good. You can almost see in there with that camera. Yeah, so you can see what I see. It just looks blocked. Now, let me poke around with this. Oh, I'm right in the slug. I'm right into the slug. So it's not really blocked. It's blocked by a solid slug. So this guy has an open slug. Now if you look at the style here, see the way this is shaped? And then the way this is shaped. So this is shaped this way to try to help the top of the tube that's inside get centered up here. That's what this shape is about. This one doesn't have that shape. It could be something else in there that's supposed to center up. Okay, we're ready to go then. I just have to have two different alignment tools for the two different. Oh, here we go. There's also a comment in the instructions. I don't know, did I read it? You got to keep this antenna positioned roughly where it will be positioned relative to the chassis when the radio's all back in the cabinet. It's probably up a little closer. So there's some kind of influence going on there. Okay, so to do the alignment, I want to get at top and bottom. And I want to get at all these adjustments down here, but I can't right now. So how do you get at the bottom? I'm going to take a little break here and sort this out.